Today we are going to learn about how to select people, staffing decision in organization. So I already uploaded the assigned reading for today, which is chapter 6. Announcement for Thursday. You need to install SPSS for Thursday activity. So make sure that you do install SPSS. There is a guideline on how you can install this program on your computer. You have to be in school to be able to download the SPSS and install it. So make sure you do it before you coming to school on Thursday or before Thursday. And because last week we couldn't take quiz because we were running out of time, so this week we are going to take a quiz on Thursday, but the quiz material will be for the week 6 material, not this week material. Let's take a look at the sequential view of stepping process. So what happened once people apply for a job in organization? So do you see the first stage is identification of applicants. So you're recruiting people. So the organization, they go to university to recruit people, or they have an advertisement, or they have website, so they can attract a new group of applicants. And after that, they go through preliminary assessment using application form. So this will be like some type of information like biodata, or you can do they can do an interview. Nowadays, I heard Google's are using a lot of those virtual AI interviews, right? So the designing of application form and how you're going to assess someone's resume, if that fit with the job or not, and also designing of the interview process, it will be based on the job analysis, right? So remember you did the job analysis homework. So based on that job analysis, you do some preliminary assessment. After the preliminary assessment, which is like the first cut, we do the formal assessment. Like they take a test, they do the structure interview, or if normally if this is for not the entry level but the mid-level manager or upper level manager, sometimes they go through the assessment center evaluation, right? For these kind of selection tools or assessment that are used for selection, biopsychologists need to develop and validate those assessment methods, right? And making sure that those methods are reliable and also they are valid. So these are the formal role of biopsychologists involved in selection and promotion process. And after that, they make the decision and they forward the recommendation to the management. And then they are going to do some background check like criminal record or the drug test or physical examination, make sure that they are fit enough to do a job. And then they finally get a placement. So when it comes to staffing or selections, all the materials this week will be about the criterion related validity. Do you remember there was like 3 different types of validity that we learned? So the first type that we learned was criterion related validity, which is being able to predict using, for example, the conscientiousness score. If someone's conscientiousness is 4, right? Can we predict the person's job performance? Right? 4 versus 5. Can we predict the 4 will be lower job performance than 5? Do you remember the first week we drew the regression line, the simple regression line, so that we can calculate the expected Y score based on the score on X. And we were also able to calculate the percentage of error when we were using to predict job performance using conscientiousness score, right? So these are all the concepts that's preparing us being able to select people, right, with a better confidence and less error. And this is all related to criterion-related validity. So do we need to do all these things for all different types of occasions as long as we select people? No, not really. So it depending on utility of this selection procedure is depending on selection ratio. So if available job is 10 and the number of people apply for the job is 10, then everyone is going to get a job, right? There's no selections. So the selection ratio will be 1 in this case. But the number of available jobs is 10, and then there's 100 of people apply for the job, right? The selection ratio is 1 to 100. So as you have lower selection ratio, it's important to paying attention to the stepping procedure. It is worse to invest if you have lower selection ratio to the selection method and criterion-related validity, because if you have available job is 10 and then number of people who apply for the job is like 8, what's the point, right? Everyone will get a job. So selection, this kind of selection studies and research on selections are oftentimes for those jobs that are highly competitive. Like everyone wants to, for example, get a job in Samsung, right? It's highly competitive. Then the companies are willing to develop and use more scientifically valid selection method than like some other jobs that are not really popular. So remember this kind of graph that we had for week 1, I think it was week 2 activity. So if we know someone's conscientiousness score and then correlation of the conscientiousness score with their job performance, then we can draw a regression line so that we can be able to predict. So if someone's having this conscientious score of this, the predicted job performance will be like this. When we make predictions, we make some errors, right? So we make errors when we are making prediction. It's not like all our predictions are going to be turn out to be correct. Every prediction has some errors, and there are 2 different types of errors. So I want to talk about that one. So let's say that This is conscientious score. This is a performance, right? And then you thought, okay, let's select a person who has conscientiousness score of 3 or higher, right? So we take these people, right? And then we say, these people, sorry, we decide you are not selected for this round, blah, 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 right? So when you make these predictions, and then once they start their jobs in organizations, then let's say the performance rating is going from 1 to 5, and then someone with a rating of 4 out of 5 is considered as successful. Right? Let's say that this is like a number of publications that you need to have, number of contract that you need to earn or something, right? Publication. So if you're more than 4, then you are successful in a job. If you're less than 4, then you're not successful. Right? So this group of people that you predicted they are going to be successful, and then they turn out to be successful because they publish more than 4. So this is true. Positive. You say yes. You say yes, so that means positive, and that will turn out to be true, right? How about this one here? In here, you say no, right? Because this is, you cut off, because it's a conscientiousness score of less than 3. You say no, and it turns out to be a failure. They are turning out to be failure. They're publishing less than 4. So this is true. Negative. You say negative. And then that was true. Right? How about here? How about here? Right? So this group of people, you say yes. So you hire these people, right? So it's positive. But turns out to be false. So they're publishing less than 4. So this is a false positive. So this is error. Prediction error. You predicted this person, these people will be successful, but turns out to be not. So it's a false positive, so it's an error. How about here? Right? You say no. Because based on conscientious score, it's less than 3. Right? So it's a negative. But they turn out to be really good. They're publishing more than 4. So they turn out to be successful. So this is false, negative. So this is also error. Because you should have not say no to these people because they turns out to be successful. Okay? So prediction errors is false positive and false negative. And there's a true positive and there's a true negative. So when you're making decision, so let's say the distribution looks like this. And then there's a criterion cutoff so that some, so this can be supervisory rating, this can be like turnover, the turnover ratio, right? Or customer satisfaction rating, student evaluations, amount of accident, whatever. So there is some kind of performance indicator, performance measure. And then if someone is better than this, then it's considered to be successful or unsuccessful, right? And then predictor score, it can be the aptitude test score, or it can be GPA. If you are applying for graduate school, it can be GPA or the test score, right? And based on the test score, we cut off people to accept those people who are better than this. We accept them. Those people who are worse than some standard, we say we reject them. So there's two cutoff. That's why there's a 4 quadrant that are created. So overall decision accuracy will be the entire A plus B plus C plus D, right? And then on top, it will be A plus B. So that will be the overall decision accuracy formula. Okay? Because those are the C and D are the errors. A and B are the true positive and true negative. So a little bit about cutoff score. So cutoff score is specified point in distribution of score below which candidates are getting rejected. So let's say you're not qualified if you're getting 100 or less. 100 is possible in TOEFL, TOEIC. I don't know. So maybe you are not qualified if you have TOEIC score of 800 or less, right? So that is the cutoff score. So raising cut score will result in fewer false positive, but more false negatives. And there is a strategy for determining cut score depending on situation. So this may be confusing without a demonstration. So let me go to the next slide and give you more of the explanation. So let's look at this, right? Let's say that your cutoff score is 50. And then you decide to raise your score, cutoff score from 50 to 70. Right? Then what happened to the errors? So now this is your new cutoff score, right? Then what is this? What is this area that got smaller? Right? This was before and this is after, right? So these are a group of people you say, yes, welcome, right? But turns out to be not successful. They failed their performance once they got a job. So these are the false positive. By raising a cutoff score, you have smaller false positive. Right? How about looking at the false negative? So you have, before that, your false, you say no, false you say no to this group of people, right? But they turns out to be really good. Yeah. But now by raising this score, you have bigger increase false negative. Do you get it? So by increasing the predictor score, you have more false negative. So that's what the previous point indicate. Let's look at so I want you to do some, thinking exercise. What will happen if you lower the cutoff score? What errors will increase and what error will decrease? So you can do some exercise about it. All right. And then where we are going to put the cutoff score or which errors should we care more is depending on the type of job. So let's say that the job of pilot who's driving the airplane or brain surgeons dealing with the people's life. Right? Which area that we want to which error do we want to minimize? So we want to minimize, in this case, we want to minimize the error of false positive here, right? We don't want to have a surgeon who we say yes, and then turns out to be a failure. So he cannot perform a surgery. We don't want that because the job is quite significant and it depends on a lot of people's life, right? So in that case, we want to minimize the false positive. Therefore, what we do to minimize false positive, we raise the cutoff score. So make it really difficult to become brain surgeon or airline pilot because we want to minimize false positive. Okay? How about the sales representatives who's like commission based? So if he earns like 100, the company get like 40% of it or something like that. A lot of pyramid schemes running like that, right? In case of sales representative, we want to minimize false negative, right? What if we say no to this person who wants to become sales representative for our organization because he didn't really perform well on the predictor, but so that he end up going to another organization, another sales company, and becomes like the sales king or sales queen. We don't want to happen, right? It's like we have less damage if the person cannot perform well. So in that case, we want to minimize the false negative, the C. So how to decrease false negative? By decreasing, so make it really easy to enter the job. So by decreasing the predictor score, okay, as long as you got 25 out of 100 on this test, you can become sales representatives and you can try out, right? Because there's less things to lose for organizations, for that types of organizations, by hiring someone who's like having less predictor, and then you never know if that person will become successful. And how can we establish cutoff score? Where do we cut? Once you take the exams and like measurement of those applicant, then where do you cut? There's two different methods to cut. The first one is criterion reference cut score. So you consider desirable level of performance and find the test score corresponding to that level. So for example, like this, and then you have regression line like this, and then this is performance, predicted performance score, right? Okay, so in this organization, we want to make sure that all the selected leader performing at this level, like 80. And then we find where this is corresponding to the level of assessment center measurement, right? Assessment center score or something like that, right? So here, so that's where we cut off. That's where we cut off score. Okay? So that is called criterion reference cutoff score. Or what we can do is norm reference cut score. So this is based on some index of test taker score rather than any notion of job performance. So this one, we don't look at the regression, like where you're going, where you're going to predict it, performance score. No, we don't do these things, right? So it's more like, okay, we will select like top 20% in this test score, test takers. Or we will, no matter how many of those people who apply and took a test, we are going to only select like 500 of those people. It can be 500 out of 1,000 or 10,000. We just have opening of 500. So we are going to only select 500 people. So there's a little connection between the score and any aspect of performance. And companies use this case for a small selection ratio. So that means if the job is highly competitive, like high-level government job, government servant job, or big companies, they often use norm reference cut scores, right? So you may be familiar with this kind of test taking preparation books or tuition center 학원, where you learn how to take this test to enter into a big company because everyone wants to enter into big company, and then they predict. Sometimes they predict your job performance, or sometimes because there's so many people, even if you can perform well once you get a job, because so many people, they often use norm reference cut score. So okay, this year opening is only 50 people in the whole company. So let's look at the cutoff score, right? So same cutoff score, but how it differ on difficulty of the job. So let's say that this is an easy job. So like effort based, as long as you put effort, you can do well. The job complexity is quite low level, right? So something like a driving. Driving is relatively easy compared to become a CEO. It's quite complex, right? The CEO need to do a lot of different types of tasks and social interaction, judgment and decision making, those kind of things, right? So majority of people can do well on this job. So let's say that your cutoff score is like this, right? So this one, it will be true positive, right? You say yes, and then because this is easy, very easy, like only a small portion, like 5% all those people who apply for the job will not be successful. So only 5% of people will fail, right? So you will have a lot of true positive in this case. And because this is very easy job, there'll be a lot of case for the false negative. You say no, but they could have performed well once they got a job because this job is pretty easy, right? False negative is also big for the easy job. Let's look at the hard job, right? Very difficult job, like a brain surgeon or astronaut or driving airplane or becoming a CEO, something like that. So because this is so difficult to perform well, the success ratio is tiny. It's a tiny, right? And majority of them are, if assuming it's the same cutoff, so this one in the easy job, this score was very low here, right? Then now the difficult job, it moved up, right? So what is this area then? What is this area? We say yes, but they turn out to be not successful, right? So this is false positive. So we have a lot of false positive for a difficult job. And what is this, right? This is, we say no, and it turns out to be a failure. So this is true negative. How about cutoff score? Same cutoff score. But there's no relationship. There's no relationship between your predictor and performance. Let's say the predictor is graphology. How beautiful your handwriting is, right? And your job performance. There's absolutely no relationship. So that means there's many people who have beautiful font, their writing is so beautiful, but they're performing really well, like this, on the job really well, or their writing is beautiful, but they're not really performing well, right? So it's about equal chance, right? And also, your writing is horrible, but it turns out to be successful, right? Your writing is horrible, turns out to be failure, right? So there's so much error that you are making it because there's no relationship. You see the round? So correlation of this round is R equal 0. So that means that selection doesn't matter. You can just do the random selection. It's basically saying that you are just selecting people randomly, just lottery or something, right? Because there's no relationship. So by using the low validity predictor like this, if you're adding graphology on predicting job performance, you're just wasting time and money that are used to measure the graphology because there's no relationship. No relationship with job performance. Another concept that is important when you are making a prediction using the test score, prediction of the job performance using the test score is standard error of measurement. So remember, there's concept of reliability of the test. So reliability is something that we can calculate. Reliability, let's say inter-item reliability, right? So inter-item reliability is the average correlation among items. Inter-rater reliability is a correlation between the two raters. Test-retest reliability is a relationship between test 1, so maybe IQ test when you are 8 years old, and then IQ test when you are 9 years old. What is the correlation? So those are the reliability of the test. And those selection tests have the reliability. Do you remember that aptitude test that a lot of Korean companies use? When you take a look, they calculate inter-item reliability. So that will be the reliability of the test, how reliable, consistent the test score is. And standard error of measurement equal to standard deviation of the test score multiplied by square root of 1 minus reliability of the score. So that means how much error your observed score have. So for example, is 80. So let's say that some candidate A have a score of 80 and candidate B have a score of 82. Are they really different? 80 versus 82? Or is that within the range of error? The range of standard error of the management. So the formula is the observed score is equal to true score plus minus, right? So this is true score and plus minus standard error of measurement, standard error of measurement, right? So when you have low level of if your test have low reliability, then you will have larger error that you are making. Okay? So your error size will be larger if your reliability is low. So let's assume that test score of 80 and then standard error of measurement was 5. Then we will say that 80 and 81 are not really different, right? But 80 and 86 are different, right? Because that's out of standard error of measurement, right? So what we can say is that let's say that the test takers, the maximum test score of a person, so that the test was the potential test score is 1 to 100. And the maximum, the person who got the highest score was 85 on that test, on that aptitude test for the entrance exam for the big companies. And when you decide, okay, who should we bring in for the second round, right? Because the first round is normally paper and pencil test or interviews using AI, right? But after that, we invite those people for the actual face-to-face interview, more in-depth testing. So who should we invite? If the person who got the high score was 85, then we know using the standard error of the measurement, we can say that, okay, we can invite 80, 81, 82, 83, 84, as well as 85, because they are all within the standard error of measurement. Because we cannot say that they are really different, because they are within the range of the error, right? And then after we invite those people for a more in-depth interview, then who should we invite the next? Right? It will be, because now the high score will be 79. So 79, 78, 77, 76, and 75. So we can invite, the next round will be another 5, because we will go down with the unit of standard error of measurement. So that's how we invite people, normally, how we invite people to the next round. All right. So using multiple predictor and choosing a candidate. So let's look at this. So this is candidate A, and the score of oral communication, written communication, cognitive ability, their previous experience, and their conscientiousness score, and this is total score. Okay. So candidate B have communication score, written communication score, cognitive ability, experience, and conscience scores. And we have scores for every candidate. Then how can we combine this score so that we predict their job performance? How we can combine the score to select people? So there's 2 ways. The first one is compensatory way. The second one is non-compensatory way. The compensatory way is also called statistical way, and then there is something called clinical way. And in the non-compensatory way, it is like most often used is a hurdle approach. So we are going to talk about how they are different. So far we use the single predictor, like a conscientious score, GPA, to predict their job performance. But in reality, we have multiple predictors and we have multiple scores. We're not just asking someone's GPA, college GPA, and decide to accept the person, okay, you can work in this company. We have different scores. We have multiple predictors, right? Then how can we combine these multiple predictors? So the first one is statistical way. Second one is clinical way, which is, by the way, no, don't use clinical way. And the third one is hurdle approach, which is non-compensatory approach. Multiple predictors, or what we call compensatory models. What is recommended is statistical combination. Simple regression, multiple regressions. So predict the score of the college performance is equal to high school GPA, conscientiousness ratings, and leadership ratings, for example. So we're using multiple regression. So remember in week 2, we did a simple regression where we have 1 predictor. Now we have adding 2 predictor, 3 predictor, 5 different predictors into the equation. So this coming Thursday, using SPSS, we are going to do multiple predictions. So multiple regressions. So that is statistical combination. That's what big companies are using. Clinical combination is the expert, someone like a CEO or the supervisor who worked in that role for many years, decide, looking at those numbers, looking at the table, right, previous tables, and then decide to weight, how they're going to weight. Oh, I think oral communication is important, so I will give you oral communication like 30%. Written communication, based on my experience, is not really important, so it's only have like 10%. Cognitive ability, not really important, so it will have 0%. Experience, I think experience is really important based on my experience, so experience will get like 40%. So there's something like that. So someone like CEO or people who were in the field for many years, they will combine, they decide how they're going to combine these predictors. accumulated studies of last 100 years says statistical combination is better than clinical. However, experts often think that their judgment is better, right? So that's the problems. But so more information about this, how the statistical combination is much better than clinical combination, is also covered in this book by psychologist. The book is called Noise. Okay? It's basically talking about errors when you are making decisions. So they mainly talk about the error that judges make, like same types of crime, same types of plaintiff, but they have totally different jail times because they're using clinical combinations. And then, so how that is a problem, how we can minimize those things. So this book is covering a lot of those things, topics. It's quite interesting. If you want to learn more about it, you can read this. But this is quite thick. I don't know if you will have time to read these things. But yeah, so that's pretty interesting book that you can read. So one of the ways you can increase the predictor validity is not using clinical combination. And then a lot of companies nowadays they try to use AI to make the predictions, right? To increase their percentage of explained variables. Problem with just relying on AI to come up with a formula. This is basically formula to select people, is that if you rely too much on AI, that if you're relying on AI, you don't understand the literature or theoretical reasoning behind why certain predictor is better predictor than others, right? You lose sight of why, the theoretical understanding. But theoretical understanding is critical to accumulate and then defining your validity of selection method over time. Do you remember this figure that I always draw? Right? This is measure of, for example, individual difference, like this is predictor, this is measure of job performance, right? This is theoretical job performance, and this is theoretical individual difference. Right? What AI is doing is because they cannot think. They're not psychologists. They're this now at this stage. Maybe once we have better AI, maybe they can overcome this. But only this, they're good at calculation. They're good at quickly running multiple regression and then calculate the best formula, come up with the optimal formula that maximize it, right? But what IO psychologists are doing is, they know this, but their formula is based on understanding of theoretical concept, the theoretical linkage between independent variable and job performance, and also the concept validity of job performance and theoretical performance. Right? So last week, what we did was how this measure of job performance have problems, right? It could be deficiency or contamination. So that's how psychologists are thinking, but that's not how AI is thinking. So AI, they're not really thinking, right? They're just calculating things. They're just big, giant calculator. So that's why there's limitation of relying on AI, because psychologists can do all those, but AI can only do that. And what we want is understanding, linking individual difference measure, and try to capture some of those theoretical job performance. Okay. So multiple regression analysis is compensatory approach. They use a multiple regression analysis and they result in equation for combining test score into predicted performance score. So why do we call it compensatory approach? So let's look at the formula, right? So the job performance, predicted job performance equal 3 multiplied by high school GPA plus 4 multiplied by conscientiousness ratings. Let's say this is the formula. This is compensatory approach because let's say someone is really low in GPA of 2, right? But if you have high level of conscientious score, you can compensate for the your low GPA. Let's say you have conscientiousness ratings of 5, the maximum of 5, right? Then your total score will be 6 multiplied by 20 will be 26, right? So you can still have really high score, high predicted job performance score. That's why we call compensatory approach. Cross-validation. Cross-validation is finding a, let's say that you use this formula. You use this formula to predict people's college GPA, how well the person will do in this college once they get in, right? Then cross-validation means that would this formula will still work after 10 years. So let's say that you use this formula for year of 2025, the batch of 2025. Would this formula will still work if you do it in 2035, right? Or should we use different formula? Maybe after 10 years, there's a less emphasis on GPA, but more emphasis on conscientious score. So the formula will be y equal like 2 of GPA plus 5 of conscientious score. Another close validation is going to another organization. So maybe this formula works for the Korean university. Would this formula work for some other university? So that is cross-validation. So the formula work for selecting, let's say, Samsung employee may not work for the selecting people in public organization or government organization. So you need to do, before you actually use that selection formula, selection method, you need to do a cross-validation. So multiple predictors guideline. This is some of the information that we are going to learn in Thursday. So when you have multiple predictor, try to predict the job performance. The predictors should be correlated with performance, right? There should be positive, significant correlation with the job performance. And then you don't want to have too much overlap between the predictor. So let's say you have two predictors. One is cognitive ability. The other one is personality, like extroversion. We don't want the extroversion to be highly correlated with the cognitive ability, right? And because you will have more overlap between the two predictor, then there will be less of the unique variance explained by one predictor. Right? All right, so are predictors compensatory? Yeah, if you have to think about these predictors are compensatory. Some predictors are not compensatory. So that is not really negotiable. So for example, for hiring of airplane pilot, knowledge and vision. So you need to have knowledge, but also you need to have knowledge of how to drive an airplane, but you also need to have a good vision. That is just not negotiable. So if someone have like nearly zero vision and then really high knowledge, but you cannot still hire the person as a pilot because pilot need to be able to see. So it's not negotiable. So that means you need to put that true predictor into a hurdle approach instead of compensatory approach. You need to put those two predictor into non-compensatory approach. So let's look at relationship between predictor, overlap, and criterion predictions. Let's look at this one. So in a all three diagram have two predictors. So diagram, if you look at this predictor, maybe this is a cognitive ability, right? And maybe this is someone's extroversion or their agreeableness have overlap with the job performance. There's positive correlations, right? So you want to have predictor relationship with criterion. So this is this here with the predictor 1, and this is here is predictor 2, right? And there are some overlap between the two, but I think this relationship is looking pretty good, given that the overall by using this predictor 1 and predictor 2, you can explain like I think this may be like 40% of variance. You can predict 40% of variance in job performance. So I think this is pretty good, right? How about A? All right. So predictor 1 have relationship with the job performance, but compared to this, it's a lot smaller, right? So I would say it's not really better than the diagram B predictors, right? So like here, predictor 2 have relationship with predictor criterion, but it's smaller. So there's like less variance you can explain in job performance using these two predictors. So overall, you can predict this much. I think this maybe is like 10%. So I would use maybe this was like which university you coming from, right? And then this one can be the recommendation letter or something. Yeah. There's very small overlap between predictor 1 and predictor 2, so I think that is pretty good, but the overall predicted percentage is important. And so that's why the formula B using this predictor is better than the A using these two predictors. Okay. Let's look at a C diagram, right? So I think this is very typical of a predictor 1. Maybe predictor 1 is the emotional stability. And this overlap with the criterion. So that's good, right? Predictor 2 also do overlap with the criterion, the job performance. Yeah, here. So it looks pretty good, right? But there is significant overlap between predictor 1 and predictor 2, right? So if you have predictor 1, adding predictor 2 do not make that much of difference in increasing your explained variance. So how much of the variance do you explain by adding predictor 2? Is here, you see? Here, here. So this is a value. This is literally the value of adding predictor 2 is minuscule because there's so much overlap between predictor 1 and predictor 2. So what is predictor 2? That is EQ score. Okay, guys? This is very typical of EQ score. EQ score, it's not that EQ does not matter. EQ matters, of course. Emotionally intelligent does matter. But the measure of EQ has such high overlap with the person's personality or ability so that it doesn't have value added as a predictor. If you already have emotional stability or cognitive ability or personality, any types of valid personality tests like Big Five or Hexaco into your formula, adding EQ score does not make difference at all. You just waste money and time because EQ test is have really low reliability and the validity is overlapping with the existing test score. Okay, so the ideal choice will be finding out those those predictor that looks like B, so that it does predict job performance, but also there is no significant overlap with existing predictors. So when you're looking at the EQ, this is overlap. This is overlap between the predictor 1 and predictor 2. So that's why it's very sucky. Yeah. Okay, so we talk about compensatory approach. Let's talk about hurdles approach. Hurdle approach is any point in selection process, individuals are knocked out of assessment process. For example, there's a minimum score for firefighters, right? So minimum requirement for firefighters in terms of their physical test. And hurdle approach is non-compensatory. So you cannot make up for poor performance later. So if you fail the physical test, then you are out. You are out of the games, right? So there are multiple hurdles normally. So, and at each stage, candidate who cannot meet the minimum, like they can do the physical test, they can do English communication test. If you cannot do that, then you get knocked out. And organization, they put more expensive hurdles placed later. So in the beginning, it can be physical examination test, make sure you're physically fit if there's a height standard, then they measure it because measuring is quite cheap of the height. But when it comes to only, so they narrow down the application pool, and then once it comes down to like very small number of people, then they do more serious examinations, serious tests that require more money and time. So for example, to be assigned as a CEO, maybe you can do like hurdles, like cognitive ability test, assessment center test, next one, and then after the person passes all those things, then final stage you may have a one-to-one interview with a clinical psychologist, making sure this future CEO doesn't have any of those abnormal personality or mental disease or something like that. Okay. All right. So Thursday we are going to have in-class activity, and you need to install SPSS. And midterm exam. For the midterm exam, you also need to know how to do SPSS. Some of the question will be about it. So I highly recommend you to install the SPSS, and then there will be quiz based on the last week's materials. Okay. All right. See you.